Hey, don't call me Chris. All right, there we go. And it's 3 repeating. It comes out even to 1.14333333333333. And then can't we figure out the frequencies? I think we can, right? And in this case, our velocity is this. We're doing, basically the frequency is going to be velocity over wavelength, right? Same thing it was here. And it comes from this, right? So 343 meters per second divided by 3.43 meters is 100 hertz. Any guesses what this will be and this will be? 100, 200, 300. There we go. Let's write it down anyway, right? 343 divided by 1.715. Hey, that's 200. 343 over 1.1433333 divided by 1.143. Hey, it comes out to 300 exactly. Look at that. Right? So again, with this guy you have the same pattern. This is 1 times the fundamental, right? This is 2 times the fundamental. This is 3 times the fundamental. Yeah? What does that sound like on a recorder? Are you ready for this? Well, all right. Are you ready for this? So like, all I'm doing is blowing harder. That makes the next one go. I think that's the same thing on a trumpet, right? You have to change your a little bit too, right? I learned they call it embouchure instead of fart sound. Because it sounds a whole lot better to say I'm working on my embouchure. Rather, yeah. Okay, are you ready for the next one? Isn't that a 5th? Twinkle, twinkle, right? And then the next one should be a 4th. Are we ready? Here comes the bride. Da, 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 da. That's a 4th. Then, yeah. And then do bugles have valves? No, they don't. What songs can you play on a bugle? Then we need like hearing protection for the rest of the song. Thank you. All right, what's the next one? How do you feel the excitement? It's that one. It's, yeah. I want to learn physics. All right. All right, let's draw these guys. Yeah, they're not really the same length, are they? Right? Draw them real nice. This guy's a 1/3 of the way, remember? The Jesus fish.
Oh, hey guys.
And then this is a 1/5 of the way. Draw it about 1/5 of the way and then split the difference. I'm like giving you all these esoteric tips on how to draw the perfect waveform. You guys are all just like, yeah, whatever.
Hey, how do you know what my
And then these pipes are 1.715 meters. Same as these pipes. The velocity is still 343 meters per second, right? And then this guy is, well, 1.715 is 1/4 wavelength, right? Isn't that just 1/4? And then here, how many quarters here?
2, 3.
It's a rough day. Yeah, 3. 1.715. It's 3 quarters. How many quarters?
5.
Oh, you left something here.
Oh, yeah.
Did you? Is there a Hayden Anderson? I thought it said Haley.
No.
Looks a lot like. That's why I write on the board, because I'm such a spaz that I forget that between like one day and the next. Okay, so this is 5 quarters. I actually asked your mom if she had a daughter named Haley. It looks like Haley, doesn't it? A little bit, if you don't look at it very carefully. Don't look at it carefully. It looks like Haley. Haley Anderson. Yeah, it does. No?
Maybe if you're like blinking really quickly.
All right. So 1.715 times 4, 6.86. And then this guy is 1.715 times 4 divided by 3, 2.82866666666. Do you guys ever see there's these horrible movies that were like out in the 80s? I'm sure they're like somebody like Amnesty International got rid of them, but it was like this skinned grizzly bear that would come around and just slash people up, called Prophecy. Okay. It was scary when that skinned grizzly bear was ripping people up. That was like a pretty frightening part of the movie. Times 4 divided by 5. It wasn't really supposed to be a skinned grizzly bear, but that's what it was. Yeah. Notice, by the way, do you see that there's a different geometry going on here? There's 1 part, 3 parts, 5 parts. This was it went up by 2s, right? This is 1 part, 2 parts, 3 parts, right? So I'm expecting a different overtone series, yeah.
Yep. Is that why tribes are 1, 3, 5, and then 2, 1?
I don't know. Maybe. I don't think so, but it might be unrelated, but maybe it is related. I don't know. Okay, so anyway, let's go ahead and do this. 343 divided by meters per second divided by 6.86. And I'm doing, again, if you're tuning in late to this broadcast, I'm just using this formula, which comes from this, right? V is F lambda. So F is always going to be V divided by lambda, right? So how many of these waves fit into 343 meters of distance? They have to go by this frequently. 343 divided by 6.86. 50 of them have to go by a second. They go by with a frequency of 50 hertz. Yeah? 50 waves per second, 50 cycles per second. Right? Any guesses what this will be?
150.
Yeah, if it follows this pattern, it'll be 100, but it doesn't follow that pattern. So let's see. 343 meters per second divided by 2.286, repeating. So 343, whoops, divided by 2.2866666666. It turns out this is 150. Now, does anybody want to recalibrate? What's this one going to be?
250.
Yeah, there we go. Probably that's the pattern, right? 135.
Yeah.
Right? Okay. So 1.715 divided by 1.372. Whoops. 343 divided by 1.372. All right, now. Got somebody, right? Okay. Class. So the relationship now with this one is different. This one is 1F1, but the next one it plays is not the octave. It's not 2F1. The next one it plays is 3F1. And the next one it plays is 5F1. Okay? So what that means, if you recall 3F1, 2F1 is the octave, 3F1 is the fifth above that octave, right? So listen to this. This is one end fixed, one end open. Same geometry, right? The octave is bop and the fifth is bop. So I'm gonna overdrive this. I'm gonna get the next harmonic, which is very hard to do. Okay? You hear it? It's that note, right? It's that fifth. It's not an octave. It's an octave and a fifth, right? It cannot play the octave. These things never, there's no octave in the middle there because of the geometry of this. This is not at all important to music, but if you ever blow too hard on a panpipe, keep that in mind.